to isolating variables. Right? Remember isolating? You have to get the variable by itself. Get the variable by itself. Okay, now you guys are fortunate because they're going to tell us what variable to look for here. Okay. In number one, they're asking us to find y, solve for y. So I'm going to go ahead and put my little dotted line there. And what I like to do is in my equation, I like to go back and find the variable I'm supposed to solve for and circle it. Kind of gives me a plan of action now. Okay? So I want to get that this y by itself. It's pretty simple. There's nothing. It doesn't even have a coefficient. Well, it does, but it's one. So all I have to do is get rid of this 7x, right? I'm going to go ahead and subtract 7x from both sides. Now, I'm going to put it, offset it over here because I don't want to make the mistake of taking 8 minus 7x and my answer to be 1x. I don't want to do that because these are unlike terms, right? If this had an 8x, it'd be okay. So these cancel out. I have my y, and then I have my 8 minus 7x. Okay. Now, being the mathematical teacher that I am, I like things in order because of my OCD or something. I like my algebraic term first and then my constant term. Okay. But if you write either one of these, that's fine. This one works. This one is just if you want to make your Algebra 2 teacher really happy, put it that way. Okay? Easy. Piece of cake, right? Know how to isolate variables now. Well, we would like to say so, but things do get harder, right? All right, solve for t. So I'm going to go ahead and circle my t. There's my dotted line to help me keep organized. Now I'm looking at where my t is. I'm looking at this term. This is all one term because there's no plus or minus. In fact, it's all one operation. It's multiplication, right? There's multiplication between the p, the r, and the t. So I'm going to undo the multiplication by dividing. So I'm going to divide by the p. Don't want the p there, so I got to do it to both sides. Don't want the r there, so I'm going to divide by r. So these cancel, this cancels, and I'm left with just the t. And on this side, I have this, I think it's I over p r. And I'm done. Now you're thinking, wow, this is really easy. Cool. I don't have to teach anymore. Number 3. Solve for x. So I'm going to go over here and circle my x. This one seems like it might be a little more complicated. Well, this one does have a coefficient other than 1. It's 11. So I'm going to go ahead and get rid of that minus 9y and bring it over to the other side. So I'm going to go ahead and add 9y to both sides. And again, I'm going to offset it here so I don't make the mistake of combining those. They're not like terms. I'm going to go ahead and bring down my 11x. These cancel out. My equal sign. And I have negative 4 plus 9y. I like keeping things in order. So I put 9y plus, or actually it's a minus 4. If you put negative 4 plus 9y, you're good. Still have to get that x by itself though, right? So I got to get rid of that 11 times x. So I have to undo the multiplication, divide by the coefficient 11. Now I could put it under each one of these terms because they're, terms. I can't just do one of these. I have to do both. But I'm going to do a shortcut here and put it under both. So my 11s cancel. And I'm left with x equals this whole thing, 9y minus 4, all divided by 11. I really don't care what this right side of the equation is or what it looks like, as long as I have that x isolated. Questions thus far? Yes, sir.
Am I good to go down?
Can you what?
Am I good to go down there?
Sure. Number 4. Number 4 is a little tricky because we got something new. Got to solve for y. I have a y in this term and a y in this term. Okay. Any suggestions how to start this or how to go about this? Anyone? Anyone?
Yeah.
What?
Um, yeah.
What? How do you want me to start this?
I don't think it makes it. I don't think it makes sense anymore.
We'll try it. I mean, we got to try something, right? Let's try it.
Combine.
Combine these two. Ooh. Now, if that was an x in front of there, then they would be like terms. Then I can combine them, right? But since there's an x with this one and no x with this one, you can't combine them. It was a good try, though. Multiply. What do you want me to multiply? Want to move a y over to the other side? We could do that. Yeah. You guys got to speak up. I can't hear you. I'm half deaf. I had a suggestion, maybe possibly moving this other y over here. So I got an x times y equals 10 plus y. You want me to divide here or you want me to go back to the original? Right here? What do you want me to divide? Yeah, I mean, if I was looking at this, I might try dividing by x, right? But be careful, I can't change the value of these terms, so I have to divide each one of them by x. Now, it helps me get this y by itself, right? But now I got a complete mess over here. Now it's getting a little tricky now. So I don't know. Although this was a really good try, don't think it's going to work. That would be great if we can move the x over, but right now it's tied to that y by multiplication, right? So what math? Let me ask you this: what math operation am I going to have to do if I can't move the x over there, but I have multiplication between the two? What's going to be a good operation to try? If I have multiplication here What should I try? Yeah, division, right? I'm gonna have to somehow. I'm gonna have to divide. Now I can do a little trick here. Okay. So I'm actually gonna divide out that y. So I'm just gonna put it here for now. And I would like this to be one term. If this was one term, it'd be great. I could just divide everything by y, but I can't because then I get a 10 over y here. So I'm going to try to make this all one term. I need to make everything multiplication. I'm going to put a quantity here because that's going to force it to be a number. Then I'm going to have y times a number, right? Now, starting to look like something, isn't it? This is starting to look like something. Starting to look like something, some other property, right? Yeah, it's looking like the distributive property, right? So what if I actually use the distributive property backwards? Instead of multiplying over the parentheses, what if I divide out? What if I divide out a y? That's what this y is here. So if I take xy, divide out a y, what am I left with? In other words, I'm taking that xy and I'm dividing it by y. What am I left with? X. Good. Minus, now let's take this y, divide it out by this y. What am I left with?
One.
1, right? Anything over itself is 1. I just went from 2 terms to 1 terms because of these parentheses. Because I put parentheses in here, PEMDAS tells us, well, this is now a quantity, this is one number. You have to do that first. It's being multiplied by y. I'm not changing the value of either one of these, right? Because if I apply the distributive property, I get this right back. Claire, do you have a question? Do you see that? I can get right back to where I was by distributing. So I'm not changing the value. Now I have one term because PEMDAS, parentheses, is forcing that to be a number, that quantity. Be what? I could, but remember I have multiplication here, right? So I want to divide again to undo the multiplication. And I want to divide by this number, the quantity x minus 1. The quantity x minus 1. See how that works? I get my y by itself, and I get 10 divided by the quantity x minus 1. So I'm doing this undistribution. I call it, or there's a lot of teachers that call it undistribute, the undistribute property. It really is no such thing in math. In fact, that term isn't even used in math, but it describes real good what we're doing. So that's why we use it. Undistribute. So when you have a variable in 2 different terms on the same side of that equal sign, you're going to have to somewhere along the line do this undistribute. And it's pretty hard to understand. Okay, let's look at number 5. In fact, number 5 is going to be the same thing because they want us to solve for A. Capital A is in 2 terms.
But it's on different sides.
Hmm?
But it's on different sides.
Well, Can I get them both on the same side?
Good.
Yeah. I could just, either way, I'm going to subtract 5 capital A. These cancel. Now, I could write -5 plus A plus A. Don't, by the way, don't combine these. These are unlike terms. I could write -5A plus AB, but it would actually be easier to undistribute if I have the AB minus 5A. Now I have them on the same side of the equal sign, right? So I can divide out a capital A. Good. So AB divided by A is just B. 5A divided by A, taking out that A, is just B minus 5. Now I have multiplication between the A and this number, quantity B minus 5. So to undo multiplication, I'm going to divide, good, the quantity B minus 5. These cancel, and I have A equals 4 over the quantity B minus 5. I undistributed. Yes, sir. Sure. Must be that hour or time of the day when I did too. Oh, be careful.
It is really hard to get
Yeah, it is. It sucks. But it is. Oops, I'm sorry, I'm recording. No, it's just. All right, little b. Here's my little b. Kind of have a little issue here, right? It's kind of locked up in here in the numerator. So I don't even like fractions. This seems like a pretty simple denominator. I'm going to get rid of it. I'm going to multiply this by 5 or 5 over 1, which means I have to multiply this by 5. Because that's going to cancel that out. And I'm left with b plus 3a equals 20. Now this one's pretty simple. I'm going to subtract 3a from both sides. I'm going to put it off here to the side because these are unlike terms. So my b is going to equal 20 minus 3a, or if you want to make your algebra 2 teacher really happy, minus 3a plus 20. I know. Math. I told you guys yesterday, math is really boring for me too. Right? I do it for the money. Yeah. Well, I didn't figure that out when I went to college. Number 7, the volume of the given pyramid is found by using the formula volume equals 1/3 times length times width times height. First problem, isolate the height. So we have to isolate the h. Okay, I have all multiplication here, 1/3 times length times width times height. which means this is one term. I don't like fractions. Going to get rid of it. Easy thing to do here, multiply by 3 or 3 over 1. Have to do it to both sides of the equation. So I get 3v equals, these cancel. I have the length times the width times the height. Okay, well, all multiplication here. So I'm going to undo multiplication by dividing. Did you see that fly? Did it go across the screen? Cool. All right, don't want the length. Don't want the width. But I want the height. So my answer, 3v over length times width equals my height. So I answered part A. Then it actually gives us some value for our variables, right? Volume, V equals 240. Let's see, length equals 10. That's our length. And then we have width equals 9. Go ahead and plug them in. So 3 times V divided by L times W is going to equal my height. My V is 240. V, 240. Length is 10. Length is here. So here's my 10. Width, 9. Here's my width. So here's my width. Now I just have to do some math, arithmetic, and figure out what the height is. 3 times 240. That's right, 720. 10 times 9. Good. I got zeros there. I can wipe those out. 720 divided by 9, 90, or 72 divided by 9. Oh, not showing up. Sorry. So I have 8. And since we're in Algebra 2, the big kids math, we put labels on. Centimeters. Volume. Remember, volume is cube. Easy peasy, right? That's all, folks. Any questions on that?